protocol was invented. And in fact, that's a long enough time ago that a number of technological advances have extended IPv4 well beyond its original capacity. But we did it. We found uses for all of them. And now if we're going to keep growing the Internet, we have to move on beyond v4. The need for this was foreseen some time ago, so we have Internet Protocol version 6. One of its features is larger addresses. 360 undecillion of them. Now, that's an unimaginably large number. I'm told it's 36 followed by 36 zeros, which has a certain symmetry to it. But the important point is that we can't use them up anytime soon, even with some changes that Leo will talk about in how addresses are used in Internet Protocol version 6. But also, this is a change in the underlying technology of the Internet. So we have some work to do to make the best possible use of the new protocol. And we have I'm waiting for a slide advance here. But Larissa, maybe you should take the pointer here.
Yeah. Do you see the next slide?
No, I do not.
That is interesting. I advanced it for you. All right. I am passing the ball back to myself, and I'll advance slides for you.
Okay. Okay. My apologies to everybody, but we have actually found WebEx to be a little balky on slide advance a couple of times now. In any case, now I see it. Thank you very much. Moving on to the overview of v4 and v6. We have lots more addresses with v6. But v4 and v6 are different protocols on the wire. They perform basically the same function of moving packets around. But they are different. Hardware, operating systems, and applications that speak IPv4 need some changes to run v6. And we'll take a closer look here at what has to be done and the high level, the 30,000-foot view of how to approach it. Next, please. Before we go too much further, we need to define a key term, just so we know what we're talking about. There are various meanings of the word compatibility as it's used in these conversations. But for us, an IPv6 compatible or compliant network, device, or application is at least as functional and useful over IPv6 transport as it was when IPv4 transport is used. Over the long term, we think that IPv6, with larger addresses and more of them and some protocol features that came out of experience with v4, we think IPv6 will enable things that IPv4 could not have supported. But in the short term, the first task is to get to the point where it's just as useful. Next, please. So another way to talk about this is that v6 was intended and largely succeeds as a drop-in replacement for IPv4. Addresses are bigger. They're 4 times as many bits, so many, many trillions more actual addresses. And as a result of that, your ISP or RIR can now give you a large block, much larger than you can imagine needing. But they do act almost the same. You need IP addresses for desktops, smartphones, firewalls, printers. And because the need for v6 was foreseen some time ago, the familiar protocols mostly already work, the infrastructure protocols, such as HTTP, HTTPS, DNS, email. But there are some differences. Next, please. Drop-in still means change. It's not a perfect replacement. And you'll see more or less that you have to cope with as you look, depending on what your network does and what kind of devices you have to accommodate. For instance, in pretty good shape as far as IPv6 compatibility, recent Microsoft and Apple operating systems, desktops, the free Unix operating systems, the BSD and Linux-based ones, which are commonly used in servers, high-end routers, particularly carrier-grade routers, and those intended for large enterprises. Many specialty devices, firewalls, for instance, have some or complete IPv6 compatibility. But that's where you start getting into some of the things you have to be more careful about. Some things that are in perhaps less good shape or that you need to take a closer look at. Legacy operating systems, embedded devices such as point-of-sale credit card processors, which are designed to be rugged and inexpensive and reliable more than they're designed to be flexible as far as underlying network technology. Manufacturing and control equipment, you see some of the same limitations. And small office, home office gateways, again, because they're designed to be small and cheap rather than being particularly flexible with regards to underlying network changes. There's also a special consideration you have to be prepared to take for the fact that most IPv4 networks these days make some use of network address translation, and it's often integrated with firewall functions and address management. IPv6 doesn't make the same use of NAT, and it will take some accommodation and some planning to accommodate that. So, assess. You first have to assess where you're at, plan, and then implement. If you haven't started yet to assess, now is the time. Doesn't mean cancel your lunch break, because we're not looking at a situation that's urgent. We're looking at a situation, however, that is serious, that does require your thought and attention. Nothing that worked yesterday is going to stop working today because we have to move from IPv4 to v6. But in the end, the future of the Internet is IPv6, and you need to not be left behind. So the first place to start is to determine, where's IPv6 going to be easy for you? Where is it going to be difficult? Because that's where most of your effort is going to be. The 80-20 rule applies. So you'll find devices that don't speak IPv6. You'll find monitoring and management, because in some cases, devices that do speak IPv6, the monitoring and management tools you're used to having, even if they'll pass packets, you may not have all of the tools you're accustomed to for interacting with them and managing them. The other big area to look at is going to be your specialty and custom or in-house applications, because those were often not fundamentally designed for flexibility and maximum use of the network. That's not their core function. And generally, people are more interested in features for those applications than they are in maximum flexibility regarding the underlying network. So for instance, you have specialty document management systems in law offices, or estimating and job control systems in a construction firm. Those are not necessarily going to be v6 compatible until enough people go back to the vendors and say, no, this really matters. We have to be able to have v6 compatibility to use the software. And not all of them are there yet. Place to start may well be to find a segment of your network that's easily isolated, or set up a lab and start turning on IPv6. Start with those devices that are probably easy, and start turning on v6 and getting some experience with it and seeing where there might be weaknesses, seeing where there might be unexpected problems. And just start slowly, because you still have some time. One of the subjects that comes up early in this analysis is going to be transition technologies, or sometimes they're called coexistence technologies for IPv4 and v6. They have names like 6to4, 6RD, dual stack light, and Leo will go into more detail of what we found at ISC when we look closely at these. But the basic usefulness of them has to do with making sure that v6 networks, such as transport networks where there's no more IPv4 to be had, and v4 networks, such as legacy home user networks or some enterprise devices such as we just talked about, to make sure that they're compatible. They can still talk to each other during a transitional phase. We learned a long time in the internet that flag days are not terribly feasible. You can't change everything at once, and these technologies are to bridge that gap. Some are based on network address translation. Some encapsulate protocol packets from one protocol into the other. But next, please. There's a number of things to keep in mind. The pros of these, we went one too far ahead. The pros of these tend to be that they can help you with incremental deployment. They accommodate legacy gear that can't easily be upgraded. They accommodate new devices after you've run out of v4 addresses. And most of the use cases turn out to apply to large carriers, large end-user networks, and large enterprises that have the compatibility issues that we just talked about. And the cons, next please, you have to look at, if you're considering these technologies in your network, they add complexity, which has implications for provisioning, for troubleshooting, for adding single points of failure, such as the gateway boxes that need to be managed and monitored. These technologies also break things we're used to having, such as geolocation, some authentication and accounting software and procedures. For those of you where lawful intercept is a concern, you have to, not all of the transition technologies accommodate that, and that may be an issue for you. The takeaway is that transition technologies are for transition. They're stopgaps. They're not intended as a permanent solution, and when you plan to deploy transition technologies in your network, you want the plan to include when and how you're going to get rid of them. Next. The other topic that comes up early in the large-scale assessment of moving a network from v4 to v6 is security, as it should. One of the things we've learned about living on the internet is that we always have to be aware of network security and information security. The good news, there are few or no new security problems with IPv6, again, because it's fundamentally very similar to IPv4. It serves the same basic function, has many of the same basic concerns and issues. But the takeaway here is the gaps we just talked about do have implications for security. Some of your tools, as we said before, may not be IPv6 compatible on the same schedule as the devices that you want passing packets. This can result in some reduced situational awareness around what's going on your network and what's happening outside in the network that you talk to. There may be additional configuration of hosts and routers, servers, firewalls, all the devices in your network to support v6, particularly if you're also doing some of the transition technologies. And again, attention needs to be paid to inadvertent security weaknesses and compromises. Perhaps the most important thing to keep in mind is that your standard operating procedures and checklists may be IPv4 specific. And the most important place to exercise vigilance is in making sure that you take changes around IPv6 into account when updating operating procedures and checklists. The takeaway, again, the 30,000-foot view, is that security needs to be part of planning from the beginning. Just because that's that's one of the basic facts of life on the internet, and one of the basic facts around making any change in underlying infrastructure technology. Next. We can move now to the case study we talked about with ISC, with what our engineering folks found when we looked carefully over a long period of time, frankly over the evolution of the protocol and some of these supporting technologies. We note that what ISC is most noted for, as Larissa spoke about, is Bind, our DNS software. Bind 8 was created largely to support IPv6 when the protocol was first being standardized. Bind 9 has been IPv6 compliant since its inception. One of the key differences between v4 and v6, one of the things you'll have to look at is some of the features in v6 for host management and address management. But DHCP is still around, the familiar protocol for host configuration management. And we have been part of the standards evolution to support IPv6 in DHCP and fielding an open source implementation of DHCP v6 since 2007. ISC is also known for a number of infrastructure services. We run a DNS root name server. We run a number of other DNS services. And the case study will look at what happened in what has been happening as it goes on with moving those services, as well as putting v6 compliance into our software. But we note that ISC, our network, is 99% dual stack today. We run v4 and v6 together, side by side. And we will now ask Leo Bicknell, our senior network architect, to go sort of a little bit deeper into what ISC has done to accommodate v6 and to promote v6 deployments in the Internet. So take it away, Leo.
Hey, everybody hear me okay? Coming through good?
5 by 5.
Excellent. Yeah, my name's Leo Bicknell. I am ISC's Senior Network Architect, and as Suzanne said in that wonderful intro, we've been doing IPv6 for a very long time here. I couldn't find a specific start date, but it's been at least over 10 years ago that we turned up some of our first IPv6 networks. We needed IPv6 internally to support work on Bind. Bind version 8, particularly if you go back in the change logs, has some fascinating tidbits from the very early history of IPv6. But we had to have networks to support those features for testing early on, and then as the protocol became more mature and we ran it more places, we realized that we wanted to be ahead of our customers. We wanted to have IPv6 everywhere and understand the implications of running it, so when our customers came to us with issues, we would be able to tell them what we found and how things worked. So I'm going to kind of go through a few of the different things that ISC ran into as we've deployed IPv6 over the years, and thinking about how to group these together, I settled on the OSI model and figured we'd kind of walk through the different layers of the stack and how IPv6 affects things. And you can see here on my model I've also added 2 layers on the top, staff and management. Sometimes people kind of put these pseudo layers up there to talk about them, and I think for this discussion it's a pretty good place to discuss some of the issues. So we're going to start first at the bottom of the chart, and there's some good news here. If you talk about physical layer stuff, whoops, one too many there, Larissa. If we talk about the physical layer, you know, fiber in your walls and Cat5 cable and all those sorts of things, it all still works. There's really no changes to any of that kind of stuff. And if we look at the data link layer, you know, the Ethernet protocols, ATM protocols, that kind of stuff, there's effectively no changes at that layer as well. There can be some implications if you're a carrier or a provider who's doing, for instance, a layer 2.5 protocol like PPP over Ethernet. There's a few minor changes there, but for the most part, there's no real changes at the data link layer either. It's layer 3 where we start to have problems, and this is where everybody starts when they think about IPv6 transition. IPv4 is a layer 3 protocol, IPv6 is its layer 3 replacement. So obviously this is the place to go. And what you will have to do to deploy IPv6 is configure IPv6 addresses on all of your routers, configure your routing protocols just like in IPv4. It's really pretty much all the same steps, just duplicated for IPv6. And the good news is that the level of effort here is actually fairly moderate. Most people think this is going to be a really big job, but we find it's really actually a fairly easy job in most networks. You got to make sure your equipment supports IPv6. That's the first challenge. But once you get past that, the engineers pick up IPv6 very quickly. It's largely IPv4 with larger addresses. They do need to learn a little bit of new stuff. For instance, the protocol ND, or neighbor discovery, replaces ARP. But in instances like that, the new protocol works almost exactly like the old protocol does. So it's a really low learning curve. So most networks, and even in our network, we find that you can deploy this layer very quick, very easy, and in ISC's world, it quickly became old hat, and deploying new networks with v4 and v6 enabled is really just kind of a no-brainer and happens automatically as the fingers hit the keyboard. If we move up the stack a little bit further, though, a lot of people want to hope that IPv6 is confined to layer 3, and it's just not the case. If we look at the transport layer right above that, what we're really talking about is operating system support. Do your operating systems have stacks to take advantage of IPv6 networks? And the answer is maybe, and this is one of the first areas where it depends on how lucky you are. If you're running very recent operating systems, if you're running things like Windows 7 or any of the free Linux or BSD-based operating systems, if you're running recent Mac OS 10 systems, they're all in pretty good shape. A few of them have a couple of little rough edges, but for the most part, they really have full IPv6 support, and it's a production-grade service. But as you go back into older operating systems, you start to have a variety of problems. Operating systems like XP might need additional packages installed in order to do IPv6 properly. Embedded systems, as Suzanne talked about, may not have IPv6 transport at all, or might need to be forklifted out in order to get a new version that supports IPv6. So one of the first exercises across your network is to try and figure out what your level of support is in all your different devices. At ISC, we were in relatively good shape here because we're mostly using open source free operating systems, which have really good support. But we do have the occasional device supplied by a vendor, for instance, for testing or other things where they don't quite have the full support in there. And so you end up having to work around these devices and maybe use transition technologies or forklift them out or those sorts of things. But so you spend a lot of time here doing an assessment on your devices. If we go up the stack a little further, though, I'm going to put the next three layers together here because they all kind of go to the same problem. And that's how your applications treat IPv6. Even if you're lucky enough to have recent operating systems where the operating system is good to go, your applications still may use IP addresses. We have really obvious cases of that. If you think, for instance, of an IP address management tool, its entire purpose is to manipulate IP addresses, and so of course it needs to be updated to support IPv6. But even if you go to other tools that don't have such a direct relationship, you'll find, for instance, that the log parsing facilities may have difficulty if there's IPv6 addresses that appear in the logs. Or you may find that connection dialogues where you can put in a hostname or IP address won't take an IPv6 address in that dialog box. So there's literally hundreds of little places and applications scattered across your enterprise where you can have this sort of problem. In addition to whether or not the application supports it, you have to configure your applications to use IPv6. A simple example would be if you were running a web server. You might have to configure your web server software to answer requests on both a v4 and a v6 address in order for both of them to work properly. And so this is where all of your level of effort really goes into deploying IPv6. With every application that goes out there, you have to dig through it, find out if it's fully compliant, not just that it can use a v6 connection from end to end, but that all the places an address might appear work properly. And then also change all of your configuration workflow to basically configure things twice, configure it in IPv4 and configure it in IPv6. So this has implications for your change management processes, for any checklists that you have, and so on and so forth. And I really can't emphasize enough how high the level of effort here is. While ISC has had IPv6 deployed for years, we still occasionally run into problems where applications have missed one field that you can't put an IPv6 address in, or a report doesn't come out right. This is a problem that I think for most people it's going to take literally years to ferret out all the places that IP addresses appear and get software updated. And then we're going to move up to the sort of pseudo layers on here. Obviously with your staff, if you have network engineers, system administrators, support staff, they're going to have to be trained in IPv6. They're going to have to know what the addresses look like. They're going to have to know your deployment plans so that they're able to troubleshoot any problems that occur. They're going to have to know what customers are talking about when they call in for support. So there's definitely a staff retraining aspect here. But also at the management layer, this doesn't fit the usual mold for most management projects. Management really likes to take a project and say it's going to take 3 months or 3 years or however long it is and set a metric for complete and be able to mark that as done and move on. And with IPv6, you can do some of that. Certainly in terms of deploying IPv6 on your own devices, you can set good metrics and know when you're done. But part of the problem with IPv6 is it's all about communicating with other people. That's why we configure these network protocols. And I'll talk about this some later, but basically as you deploy IPv6, it's only really useful if you have other people on the network to talk to. And so you might find that you deploy it and there's not much traffic initially and you don't really find any problems. And then months later, when everybody else deploys IPv6, all of a sudden you start to notice things like the log parsing errors or other things as those addresses appear. Excuse me just a moment. So one of the things that Suzanne talked about was the transition technologies. These are a set of tools and protocols that are designed to help you to move from IPv4 to IPv6. I want to reiterate again that none of them are designed to be permanent solutions. They're designed to help get you over the hump from one to the other. And virtually all of them have significant drawbacks. We spent a fair amount of time at ISC looking at these, both in terms of having our software support some of them and using them on our own network. And what we found across the board is that, of course, it's better to use a transition technology than to not be able to communicate at all across the network. But in every case we've tried, we've found it significantly easier and less work to simply deploy a dual stack network from the start. So let's look at a few of these transition technologies and the type of drawbacks that ISC found. Down the left, we've got names of a few of the transition technologies that are involved. And across the top, I've got some of the drawbacks that we found that they had. You see, a lot of these require IPv4. As Suzanne said, we're almost out of IPv4 addresses. So many people are going to be in a situation in the near future where they're going to have to deploy basically IPv6 only networks, and technologies that require IPv4 simply aren't going to be viable. Several of these technologies are sort of one way, which means you either need to configure multiple technologies to have round-trip communication, or you might also be dependent on somebody on the other end running a sort of compatible or mirror image of the technology in order to have end-to-end communication. A bunch of these protocols basically effectively look like tunnels. And that's not necessarily a problem from a connectivity point of view, but it causes a host of other problems. Tunnels may go through your firewalls without hitting all of your firewall policy, for instance, creating security issues. Your IDS systems may not be able to look deeper into tunneled packets and see what's going on with the traffic. So it can really cause a visibility problem when you use these tunneled protocols. Some of the protocols require application layer gateways. As we looked at this, a lot of the popular protocols are very well supported and work just fine, but if you have in-house custom applications or some of the more esoteric applications, you may find that the ALG isn't aware of them, and thus they don't actually work properly through the technologies. Several of the technologies break the end-to-end model, which may be an issue with breaking things like peer-to-peer software and certain other software packages that depend on that model. And some of these technologies require CPE support. Your device has to be aware of the technologies and how to use it. And frankly, we found if you had to replace your CPE to make it aware of a transition technology, you might as well replace your CPE with a piece of technology that's aware of full dual stack IPv6 while you're there. So there's kind of really no point in those cases to using the transition technology. But I go through this because we did try several of these technologies in our network, and we looked at the various cases for them. And I want to emphasize that at the moment, ISC operates no transition technologies. All of these things were way more complicated, much harder to manage and operate than a dual stack network. A lot of people are afraid of a dual stack network, thinking it's a really complicated thing, but the reality is it's very easy. The two protocols coexist quite nicely, and it's really the simple way to do things. You might not be so lucky, though. Sometimes you can't control all the devices on your network. Either you're a service provider with customer devices you have to support, Or even in an enterprise situation, you may have devices that are supplied by a third-party vendor that you can't directly upgrade. In those cases, you might be forced to run various transition technologies in order to help you get from IPv4 to IPv6. What you need to do is make sure that they're temporary and try to run them for the shortest period of time possible. Another point that I want to re-emphasize is that in networking, we're trying to talk to other people. And thus, you might be forced, or ISC might be forced, to run some of these transition technologies just because other people on the internet are using them. If you look at technologies like 6to4 and Teredo, you don't have to run a server in order for them to work, but you might find that if the traffic volume is high, you want to keep that traffic locally on your network and run it through your own server. So the actions that other people take on the network may help shape your plan and help control what you need to do. One of the things that ISC found as we deployed IPv6 is that it really does enable a new sort of thinking. A lot of the people who talk about IPv6 addressing talk about the fact that it puts the focus on the number of subnets and not on the number of IP addresses. You know, in IPv4, if your sysadmin goes to your network engineer and says, I need you to configure a new VLAN for me, the first thing the network engineer is going to ask is, how many hosts are you going to put on it? It's all about sizing that IPv4 allocation correctly because the resource is scarce. In IPv6, that problem doesn't exist anymore. You simply put a /64 network on every single VLAN or interface, and you've got 2 to the 64th addresses, more than you'll ever use on that particular subnet. And so the concept of sort of burning IP addresses really becomes attractive. We can't do it in IPv4 because there's not enough, but in IPv6 there's more than we'll ever use. So for instance, in IPv4 you might do named-based virtual hosting, so you can conserve IP addresses. In IPv6 there's absolutely no reason to do such a thing. In IPv4 you might do your management and your service over a single IP address to conserve addresses. In IPv6 you can give your box 2 different addresses and use one for the service and one for management. We've even looked at people who've considered, for some of their services, giving a different address to every single customer that they support on that box, so that if they need to firewall it or null route it or do things like that, each one is an individual address. So IPv6 enables these things that are really pretty much impossible to do in IPv4. The other thing that we've noticed as we've deployed IPv6 is that it pushes folks further away from static addressing. We've had DHCP in IPv4 for a long time, and our product is testament to that. But IPv6 brings a lot of additional features to the table that even push you further down that dynamic road. There's stateless address auto-configuration. This is the magic way that IPv6 devices can get an address without using something like DHCP. So that's really allowing a lot of people to have a fully dynamic network from the start. But the protocol also pretty much requires that every device support multiple addresses per interface, and so you're finding support for multiple addresses in a lot more devices than used to have it. And there's new features. The example I like to use is privacy addresses. This is a set of features that allows a host to basically change its IP address automatically every few minutes, so that it can't be identified as being a particular IP address. It kind of goes back to the burning IP addresses concept from the previous point. But in all of these things, you have more IP addresses on a host, and they're moving around dynamically at a greater rate. And so you're looking at a situation where there'll be fewer and fewer hosts in your network that have a good old-fashioned static IP address on them, which also means that you're probably going to be doing a greater amount of things like dynamic DNS in your network. The largest challenge, though, and the point I want to kind of leave you with, though, is that the internet is all about interconnection, and you really are dependent on everybody else in the entire ecosystem. Even though ISC has been IPv6 enabled for a very long time, what we spend all of our staff time on at this point is working with our partners and vendors and customers on getting IPv6 deployed. We've got effort sites in over 50 locations around the world. And some of those locations have virtually 100% of the ISPs with IPv6 deployed, and others have literally nobody with IPv6 deployed besides ISC. And when it comes to communicating with other people, you know, being first or last is really kind of bad. If you're the first one to speak the new protocol, there's no one to talk to. You've done a lot of work for nothing. But if you're the last one to speak the old protocol, you're also in basically the same boat, where you run the risk of everyone else turning it off and not being able to talk to you. And so there really is a need here to watch the industry as a whole and to watch your providers and your vendors and your partners and adjust your time frames to stay more or less in step with everybody else. This transition will go smoother if we all sort of move together. So I want to hand this over now to Larissa again, and she's going to tell us a little bit how ISC can help you make the transition that we've already made.
Great, thanks a lot, Leo. So we want to talk a little bit about how ISC can help you with your IPv6 transition. So the first thing I want to do is just review, excuse me, quickly the top 5 takeaways from Suzanne and Leo's talks. I think one of the biggest things is what Leo just said. The true value of the internet is interconnection, is in our communication. Stay connected. And that means hang on to your IPv4 address space and you know, using it as long as you need to, and then make sure that you're ready for IPv6. Then you want to identify your problem areas for migration. Go back and think about all the layers that Leo talked about and what's going on in your applications as well as the lower layers there. IPv6 is not as hard as many believe it is or as hard as it seems if you prepare. So that's our real message, is that it's not too late to get ready for this and to be on top of it, but you need to plan. Don't panic, plan. And ISC can help. We would like to help. We are qualified to help, and some of the things that we do are, we talked a little bit about this earlier, we provide open source software that is IPv6 compatible. That includes our bind and DHCP. 2 other transitional protocols that we do that we didn't discuss earlier are after and then a flavor of after called after PCP. These are transitional between IPv4 and IPv6 address mechanisms that we will talk about more in another web seminar that we're going to do that's for carriers. And also, if people are interested, we can talk more about them after the session. The other things that you might not know that ISC offers are training for IPv6. We have a specific IPv6-focused training course. It's a 3-day course that covers in detail everything that we've covered here today, plus a lot more. I've attended it. It's really excellent. We also offer bind and DHCP courses that do cover the IPv6 relevant aspects of those pieces of software. And we also have consulting services which can help you with audits, planning or implementing around our software and just implementing v6 protocol, helping you figure out which technologies will work for you. And we have a support organization that provides support for our software that will help you through this process and beyond if you elect to use that. So we have a couple of special offers for people coming to this webinar today. The first one is a training seat plus consulting package. That's 1 seat and an upcoming IPv6 training course, and I will go over some of the upcoming locations. And then that comes with 8 hours of consulting to determine your potential issues and how to adhere to best practices within your network. This deal is good for 90 days, and there's a coupon code right there. And these slides will be available later. You don't need to write it down. Consulting and support package is the second one here, and that is, again, 8 hours of consulting with the same goals, determine potential issues and adhere to best practices. And then that goes with 6 months of basic support for bind, and that's our support engineers are available to answer all your questions. You can arrange for configuration reviews and other things within your support package. You just have to talk to our support folks about how to structure that. That's also valid for 90 days. And there's another, coupon code right there. So another thing that's that we're doing now is we're doing more of these web seminars, and there's quite a few coming up. Some of our web seminars are open to the general public, and some of them are for established ISC customers, but that's all, and that information is available to you on our website. The first one we're going to do is a Bind 9.8 roadmap. 9.8 is actually being released at the end of this month, so it'll be discussion of the features of that and the roadmap for upcoming Bind releases. That's March 2nd. Then we've got a Passive DNS for Security Intelligence seminar on March 8th that can help you learn about how to use our Passive DNS technology. Then the next IPv6 themed web seminar is March 23rd. That's going to focus on needs of carriers and ISPs. The Security Information Exchange is having a web seminar, so you can learn more about that program at the end of March, March 29th. Then there's going to be a DHCP v6 session on April 13th. That'll cover both what our software currently implements of DHCP v6 and what our roadmap is going forward. And then the last of our currently scheduled web seminars is going to be an IPv6 session, but specifically focused on the needs of people in the enterprise. So a little bit of a different focus from the carrier session. You can sign up for these at isc.org/webinars. And that's also where the slides will be available after the presentation. Probably, I would guess tomorrow morning would be safe. Okay. Training. So we had some questions I saw about where training is available. So this is the currently scheduled upcoming IPv6 trainings for 2011. This doesn't mean this will be all the trainings. If there's interest in a training in a specific region, you can contact us, or if your organization or a group of organizations is interested in a private training or a hosted training, please contact us. We're always very willing to do that. So you can see we've got trainings. We've got 5 v6 specific trainings coming up this year in Virginia, Amsterdam, Washington, D.C., Cape Town, South Africa, and Los Angeles. And we've also got Bind and DHCP trainings coming up this year. The URL at the bottom of the page has the full schedule and more details. And I think that's it. I'm going to take some questions. And actually, I've already got some great questions here in the chat window. So I'm going to back up a little so I can. Okay, so the first question I have here, I'm going to ask Suze or Leo to answer. This is, does IPv6 have any security features that are not available in IPv4 addressing? So if you would like to handle that.
This is Leo. I'll take a shot at it. I would say basically no. IPv6 and IPv4 at a protocol level roughly are security equivalent. There are probably a few minor esoteric details that only apply to security researchers in some real strange situations. But basically, IPv6 has the exact same security pluses and minuses that v4 does. The real difference here is with the larger address space. You might have to consider your firewall rules a bit differently. Again, people are thinking in terms of subnets instead of in terms of addresses, so it changes the thinking a little bit. And I will also say that there are a lot of security tools that have been sort of bolted on to IPv4 over the years that haven't been completely bolted on to IPv6. It's not because they can't work or don't work. They generally work the same way. It's just that the vendors haven't caught up with all of those features just yet.
Okay, thanks, Leo. Second question, just to reiterate, the slides will be available after the presentation on the isc.org webinar page. So the next question is, can we expand a bit on stateless configurations? How are endpoints requesting v6 addresses, and where are they being requested from? Parentheses, is it some IPAM tool?
Sure, Leo again. The stateless auto configuration is in fact just that. It is stateless. What it actually does is it takes the MAC address from the system and does a small transformation on it and generates a host portion of the IP address. And there are protocols at the network layer with IPv6, in particular neighbor discovery and routing advertisements, or ND and RA, that allow the host to check if there's a duplicate on the network and to get its default gateway. And so those protocols are all built into IPv6 and basically allow a device to come up, simply start using an IP address and learn its default gateway without having to deploy any additional centralized servers, no DHCP, no IPAMs, no anything else. You can disable those if you really want to, but we find most people actually really like those features.
Thank you. The next question was about training conducted in Asian Pacific countries, and the answer is that we train wherever the need arises. So I don't think we have any currently scheduled trainings in Asia, but we have done that in the past, and we or our training partner might be willing to do it again in the future. Talk to us. The next question is, do you have an IPAM tool today? And I don't think that we do, but I don't know if Leo or Suze wants to speak more to that.
Yeah, I'll take that one. We don't use an IPAM tool. We manage our IPv4 sort of the old-fashioned way. We have an internal wiki we keep track of addresses on. In IPv6, it's actually significantly easier. The model with IPv6 is to assign each site a /48. So whether you get a 48 from ARIN or from your upstream provider, or you're an ISP and you get a /32 or bigger, and then assign a /48 internally to each one of your sites, what that gives you at each site is 65,000 subnets worth of addresses. And very few sites have more subnets than that. So what we've done internally is we've simply mapped VLANs 1 to 4096 to subnets 1 to 4096. So all we actually have to track, for the most part, is which /48 is assigned to a site, and then you can actually construct the IP address range that goes with a particular VLAN automatically. And that still only uses 4096 of the 65,000 subnets, so we have plenty more available if we need to static route one to a server or do other things with them, and we just keep track of those in a list. There are IPAMs that do support IPv6. If you have a lot of customers or other complex situations, you might need those. But we actually find for most people the IP address tracking job becomes significantly simpler with IPv6.
Okay. Suze, go ahead.
Yeah, just to add to that, though, is the whole question about an IPAM in a v6 network. As Leo said, a lot of the need for it in terms of actually making the network function disappears. But the other thing that's starting to become clear is that the other piece of what IPAMs do in v4 networks is integrate with provisioning and authentication and all kinds of other network management practices that have to do with sort of the higher level pieces of what has to be done. And if you're not, to the extent that your provisioning and network management and customer management and so on are tied in with your IPAM, you end up having to look at perhaps different ways of accomplishing those same things in a network where address management looks very different.
Thank you. So then the next question is, what do you brief people on vis-a-vis IPsec within v6?
I think either of us would have something to say about that, but whoever, do you want to go first, Leo?
Yeah, I actually don't have a lot to say about it. We don't use IPsec internally very much. We do use it for a couple of things, and I know there's been a lot of hype out there about IPv6 is better for IPsec, and I suppose if you look at the headers as a hardware designer, they might be a little easier to process. But really, from an end user perspective, from a configuring it on your host perspective, it works just the same it does in IPv4. You know, if you got to debug it, you got to know the headers are in a little bit of a different order, but it's really the same. There's no better and no worse about it.
Yeah, there was an interesting history of controversy around that because there was, at one point, IPsec support was mandatory for v6, and then a lot of people came back and said that wasn't terribly practical in networks where you don't need it. People didn't want to deal with the overhead. Vendors didn't want to deal with the implementation issues around assuming that it would be used as opposed to assuming it would be an option used in particular circumstances. And so that's one of those things that sort of the assessment changed as the standards started getting out to where people could try it out in real networks. But I think that it will actually be interesting to see over time whether the demand for it is actually there, because v6 was partly designed to support IPsec better than v4 did.
Thank you. The next question asks if we have any references to recommended open source IPAM or v6 subnet calc tools.
This is Leo. I've actually been studying IPAMs internally, and of all the ones I've tried, which I won't suggest as an exhaustive list, I have found the v6 support is lacking at this point in time, and but partially with the simplification of how they work, how the addressing works. Like I said, we've just found them less necessary, at least in our deployment. But that is definitely an area where I think the technology is lagging a bit behind. As far as subnet calculators, I don't know of any out there on the web. The reality is, again, they're much less necessary. The colons are at useful boundaries, and with every subnet being a /64, you're not worried about is it a 28 or a 27 or all those other things that we do in v4. You put a /64 on every interface, and the subnet mask is always the same. One of the things that has come with IPv6 that makes life a little easier is pretty much universally the vendors have adopted the / notation. So in IPv4, you still have a lot of vendors that make you type a subnet mask as 255.255.255.0 or something like that. In v6, that would just be impractical. It would be way too long of a string of digits. So the / notation has become basically ubiquitous. So that makes life a little bit easier.
Okay. Thanks, Leo. So the next question I see here is, what is the recommended way to deal with reverse DNS on IPv6 addresses? The amount of addresses means one can't just pre-make all possible records of the DNS.
It's another one I suspect we both have something to say about. I can start. That's actually something that is, as you'd guess, coming up more and more as people look at real deployment plans for some of those same reasons having to do with provisioning systems and management and so on. And from our perspective as maintainers of bind, that's very much an open question, because various carriers and operators have different uses for v4 reverses. As you say, just populating the zone and forgetting about it is not practical. So people are looking at various possible ways of doing some of these things with dynamic updates, with other possible ways of getting around the fact that you can't really enumerate the addresses in a v6 subnet. And in terms of, and I'm going to steal Larissa's product manager hat here for a moment. In terms of what should be done with that, best practice isn't really determined yet. We hear from our customers, and we want input on what we should support in bind as far as what tools people would like to see to make managing v6 reverses easy in DNS. So we should note who's asking that question and make sure that we discuss that further, because that's actually an area that we are looking at right now in terms of how do we best support what our customers are going to need to do.
Indeed, I will do that. I just want to make one note here, which is that Karsten Strootman, who's one of our trainers through our training partner, Men and Mice, points out to me that Men and Mice has a couple of tools for IPAM and subnet calculation available and that are on their website, and they are discussed in our IPv6 training course. So that's a resource for people. That's Men and Mice, who are our training partner. And thanks, Karsten. So the next question is the IPv6 network inherently faster than IPv4? Is the packet processing faster, faster access to the network?
This is Leo. Basically, no. There's really no significant difference one way or the other. I'm going to caveat that with two small caveats. If you happen to be the guy who's designing router hardware, you probably like IPv6 better than IPv4. The packet header was rearranged in a way that is slightly easier for routers to process. That doesn't actually translate to any speed improvements. There's perhaps a little bit of hope that in the future it might translate to slightly cheaper routers as the design is easier. But from a practical point of view, there really is no change from that to anything that an end user or an operator would see. The other aspect I want to point out is right now the V6 Internet is still coming together. We definitely have large portions of the network that have not deployed dual stack IPv4 and IPv6. And so folks are working around that problem by using either transition technologies or using good old-fashioned, GRE or IP and IP tunnels. And unfortunately, one of the effects of anything that does tunneling, whether it's the transition technologies doing a pseudo tunnel or an actual GRE or IP and IP tunnel, is that they often take a suboptimal route to the destination. So there's still the case today in the IPv6 network where you see packets taking a longer path than they should due to these tunnels, but that has nothing to do with the protocol or the ability of routers to forward packets or anything like that, and it's rapidly being solved at the carrier level. So fundamentally, no, IPv6 is not any faster or slower than your IPv4 packets.
Okay, thanks. So let's see, we've got a few more questions, and I just want to say I know it's after 5 o'clock, but for anyone who wants to stick around for a few more questions, it's fine, and for the rest of you, thank you for coming. Let's see, here's a question. I heard there was an RFC out there discussing what to do when you run out of RFC 1918 address space, but I haven't been able to find it. What are other large enterprises doing when they run out of private address space besides going to IPv6?
Let me take a shot at that one. Well, Leo can go first. I think we're both happy to.
I was going to say, Suzanne may know better about if there's a specific RFC. That's not really my area of expertise, and I don't specifically know of one. I can say that there are definitely a few large carriers and enterprises who have run out of 1918 space, and there are basically two different tacks that people take forward when they do that. Option number one is to basically subdivide the network. You can partition your network and run 1918 space multiple times over in different areas. And a canonical example of that would be, for instance, a cable provider. They might have managed all of their devices nationally out of 1918 space and might switch to having 1918 space manage all the devices in a particular city or state or something like that, and then a completely separate island of the same 1918 space to manage devices in another city. It's slightly inconvenient, but on that scale it can often work. The other thing that folks do is if you have run out of RFC 1918 space, for the most part, you are able to then get public IP space. And several large providers who've used all their 1918 space have actually gone to ARIN and gotten public IP space to then continue on with their deployment because they've used that resource completely. So, Suzanne, do you have anything to add on that?
Only that there have been a couple of discussions in various groups within IETF, which is where that would have to happen. And the last couple of times it's come up, the fact is that it's not clear where the address space would come from to do that, because RFC 1918 reserves certain address ranges in IPv4, and at this point, all the others are in use, except for the blocks a few blocks, not that many, originally reserved for experimental use, which provides a certain set of problems with compatibility with network devices. So it's not immediately obvious where additional RFC 1918 type space would come from. And the last few times people have gotten involved in that discussion, it's been shelved on the grounds that, in addition to the workarounds that Leah was talking about, that frankly, if you're running networks that big and you need to expand them beyond the ability of the measures that have been put in place, you really should be looking at V6. In the long run, it's easier and cheaper. But that's obviously a difficult case to make as well. So there's really an open controversy about that.
Yeah, and let me build on that just a little bit in that a lot of folks don't realize it today, but some of your cellular network phone data and some of your cable boxes today are managed over IPv6 addresses, even though they only present an IPv4 address to you, because the folks who ran those large networks realized they were running out of RFC 1918 space and found moving the internal management functions to IPv6 a much easier option than doing anything else. So a lot of these large networks actually are V6 enabled internally, even when they don't look enabled externally yet.
Okay, thank you. We've got a few more questions here. Let's see, this one is great. We run IPv6 natively on our network now. As you said, it wasn't too hard to enable. Now we have to use transition technologies for our remote workers. So, what generic technology do you recommend for dynamic tunnels?
The technology depends definitely on your situation. You know, if you're talking individual remote workers, I would probably lean towards the sort of standard VPN solutions that enterprises have been using for years to get in remote workers for more security purposes, but you can tunnel over the current internet and give them a V6 address inside the tunnel, for instance. So that obviously works. In terms of users out on just random internet networks, certainly the 6-to-4 and Teredo protocols kind of have the widest usage base. They also have sort of the most unpredictable performance because you don't know where the gateways are going to run. So those are potential options. And certainly if you have remote workers and you happen to have a corporate arrangement for their connectivity with a provider, you should already be talking to that provider about IPv6 transport. The providers are basically only going to deploy stuff where customers demand it and pay for it and say they want it. And so you need to be telling your vendors that so that you don't have to use these transition technologies to get them connected.
Okay, thank you. Here's another one. If everything is automatically configuring, how do you hand out options from DHCP? And what can proxy the DDNS updates the way that the DHCP server does it in IPv4? So that every device in the network isn't allowed to dynamically update DNS.
So there's a lot of people, I think, who are under the belief that in IPv6 they don't need DHCP because the device can get an IP address automatically. And unfortunately, the only reason that's really working in the current situation is because the networks are still dual stacked with both V4 and V6. And here's the simplest test you can use to kind of prove yourself of this. You can set up a V6 only network in your enterprise. You know, configure your router to have no IPv4 and put an IPv6 address on it, and plug up a recent box, a Windows 7 device, a Mac OS 10, Linux box, whatever you have laying around, and let it dynamically grab an address with SLAC, stateless address auto configuration. You'll find that it does in fact get an address. It gets a default gateway. You can ping and trace route and do all those things to your heart's content. But you'll find if you open a web browser, you won't be able to see anything because you don't have a DNS server. Those protocols today have no way to pass, as you said, options, whether that's as simple as a DNS server or as complicated as you want to do a network boot and need to pass in boot servers and all sorts of other parameters. Those protocols just don't have the options. What's happening today is because folks are dual-stacked IPv4 and IPv6, the IPv4 DHCP is supplying things like DNS servers and whatnot. So when it grabs a stateless IPv6 address, it'll make, for instance, the DNS query over IPv4 to get that IPv6 address and then connect over the IPv6 part of the network. So one of the things that is very active in development right now is what does the future look like? We obviously have a DHCP server that supports IPv6. I think if you look at the likely options for a v6-only future, we're going to need something like that. But there's definitely some other folks out there looking at adding those options to, for instance, the RA protocol so that DHCP wouldn't be needed. But definitely you need to look at one of those things, and if you had DHCP v6, it could do the DNS registrations for you just like you would do in v4.
Thank you, Leo.
Yeah, just a real quick observation to sort of top all that off is that the question there goes back to exactly why DHCP v6 exists, why the standard needed to be specified, because originally the intention was that it would not be. And one of the things, again, to follow up, it would be good to, this is one of the areas where we're listening to our customers and where our standards activity comes in, because we get to take what our customers tell us about things like this back into the standards process as far as what really, how the standards need to evolve now that people are actually trying to deploy this stuff in the day-to-day internet. So thank you for the question.
Great. Well, that was the last question I had here, and a lot of people stuck around for all of them, so thank you very much. We very much appreciate your time, and we hope that we will get to talk to you soon in another seminar or another event. Bye-bye.